All right, we're 3 minutes past the hour on my clock, and so we will get started. Welcome, everyone, to the third episode of the American Spinal Injury Association's Early Career Clinician and/or Researcher webinar series, which is a bench-to-bedside view of the landscape of spinal cord injury research and medicine through the eyes of early career professionals, which is us, the organizers, hosts, and the presenters, and hopefully the audience as well. This series is a multi-part series featuring episodes focusing on a single topic in SCI research and medicine. In each episode, a dyad of presenters will give us a parallax perspective on their SCI topic of expertise, ideally one perspective being more lab-focused and one being more clinically focused. Each presentation will be 20 minutes with a 10 minutes Q&A following the presentation. And beyond sharing the emergent work of the young professionals in the SCI space that you'll see present, we also hope that this series will identify and archive the rising stars in this space and create a community for networking together with these people based on a common mission. And if you stick around till the outro, we will present to you one way you might be able to do that. So here we are for season 1, episode 3, titled Metabolic and Endocrine Function After Spinal Cord Injury, with presentations by Dr. Jia Lee and Dr. Sven Hoekstra. So Dr. Jia Lee will kick us off. She is a postdoctoral fellow in the Department of Physical Medicine and Rehabilitation at the University of Alabama, Birmingham. Her research focuses on understanding the risk factors for the development of insulin resistance and type 2 diabetes, as well as dietary interventions to improve metabolic health function in individuals with spinal cord injuries. She received her Ph.D. training at Purdue University. At UAB, she's coordinating a 5-year clinical trial that investigates the effects of a high-protein, low-carbohydrate diet on metabolic health, gut microbiome, omics, where she's an expert, and body composition, as well as quality of life in people with long-standing or chronic spinal cord injury. Her presentation today is titled Effects of Low-Carbohydrate, High-Protein Diet on the Gut Microbiome Composition and Metabolic Health in Individuals with Spinal Cord Injury. And Jia, you can start to share your screen now, and we'll see the title slide.
And my apologies, I changed my title the last minute to better reflect the topic. So it's nutrition, cardiometabolic health in individuals with spinal cord injury. And my background in nutrition, probably what I know about spinal cord injury is not as much as my audience here. So, but I still want to briefly introduce spinal cord injury for the completeness of the talk. So, spinal cord injury is a damage to the spinal cord, which is the bundle of nerves and cells responsible for sending and receiving signals from the brain to and from the rest of the body. And SCI hinders the body's ability to send and receive
Rima G, your audio is coming through.
SCI hinders the body's ability to send and receive neurological signals, which impacts sensation, movement, and bodily function. And depending on the section of the spinal cord damaged, it can be divided into different levels of injury. On the graph here, we can see there's 4 sections: the cervical, the thoracic, lumbar, and sacral sections of the spinal cord. And the figure here shows the corresponding body parts or functions that was affected. And depending on the kind of severity of injury, it can be further divided into complete injury. There's no sensory or motor function preserved in the affected area, or incomplete. There's only partial sensory or motor function preserved. I'm here mainly presenting the US data, which I'm more familiar, unfortunately. So SCI, there's about almost 18,000 new SCI cases each year. And quickly looked up around the world, there's about 250,000 to 500,000 a year. And the lifetime cost is about $1 to $5 million direct health care cost per person. And the SAE often results from vehicular accidents, falls, violence, sports, medical and surgical procedures. And the distribution of the incidence of spinal cord injury among different ethnic groups it kind of mirrors that of the US population with a slight higher proportion of patients who are non-Hispanic Black. So in addition to the apparent impairment of the physical function and sensory losses, individuals with spinal cord injury often develop many secondary health conditions, which are defined as a condition that's causally related to a disabling condition that is occurs as the result of the primary condition. Here I want to introduce some conditions we're trying to targeting by nutrition interventions. First of all, because of the lack of muscle innervation or physical inactivity and hormonal imbalances, individuals with spinal cord injury, they lose about 20 to 50% of their muscle mass in the first 6 weeks of the injury. And the muscle loss will continue until 1 year after the injury, which is considered as the chronic phase of the injury. As shown here in this graph, this shows the percentage lean body mass of patients with without spinal cord injury, that's the black bar, paraplegic and tetraplegic patients. And these are the lean mass percentage in the arm, leg, trunk, and the total body. There's an overall trend of a progressive decrease of lean mass. And conversely, we can expect that the fat mass percentage goes up because they add up to the total mass. And it's well understood that skeletal muscle mass is one of the main determinants of energy expenditure because of this muscle loss. And it may contribute to an overall reduced metabolic rate, which we can see a decrease in resting metabolic rate. And also combined with a reduced physical activity, we can expect that patients living with spinal cord injury have a total decreased energy expenditure. Because of the muscle loss, and we know skeletal muscle takes up about 70% of glucose load. Skeletal muscle takes up about 70% of a glucose load. This severe muscle loss contributes to impaired glucose metabolism, as shown here. Participants went all through a 2-hour oral glucose tolerance test. The x-axis is the time, the y-axis is the glucose and insulin. This is the insulin graph. We're seeing that compared to patients without injury, which is this black line, patients with spinal cord injury, the highlighted green line, their average glucose concentration at the 2-hour mark is above the cutoff for pre-diabetes. And the insulin concentrations are higher, indicating they are insulin resistant, which means they need more insulin for the glucose to be removed from the circulation. Another emergent secondary condition or could be contributing to secondary condition could be gut dysbiosis. So what it is a imbalance of the gut bacteria, particularly a decrease in the beneficial ones and increase in the pathogenic ones. There's tons of research in the animal models or in general populations. They're showing a link or causal relationship between gut dysbiosis and digestive systems, issues in the digestive systems, in the cardiometabolic system, central nervous system, lungs, and skeletal muscle tissues. Before I introduce some of the emerging evidence in gut dysbiosis in SCI, I want to introduce some commonly used indicators or measurements for gut microbiome composition. One of them is alpha diversity. It's a measurement of the microbiome diversity within a sample. So it can be a richness indicator, which is a measure of the number of species in a sample, or an evenness, which is a measure of the relative abundance of different species that make up the richness in that sample. I'll give you a visual example to help you understand. So we have two samples here. Each of them have 4 different colors, and their distribution is the same. So we can say the two samples, they're equally rich and even. And here, the sample up here only have 2 colors. The one in the below, it has 4 colors. So we can say sample 4 is richer but less even. And here they all have 4 colors, but sample 3, so they're equally rich, but sample 3 is more evenly distributed. So sample 3 or sample 4 is less even, sample 4 is more even. Another indicator is beta diversity. It's a measure of the microbiome diversity between the samples, basically how different the samples are. So when there are 2 more samples, we can calculate the beta diversity for every pair of the sample to see what's their different, how far they're from each other. So we have groups of samples. We can see the distance between the groups compared to the distance within the group. And then this allows us to visualize how the group or whether the groups are different. As seen here is an example. We can see the red group is far from the blue group, and the samples within the blue group, they're kind of closer to each other. So this is the beta diversity, or how we can visualize beta diversity. So one of the first research emerging from regarding gut dysbiosis is about 5-6 years ago. They looked at mice with a T9 spinal cord injury. They looked at their 2 samples, 3, 7, 17, 28 days after injury, and compared to a sham control. And the red samples here, they are SCI samples, and the blues are the sham control samples. And we can see we use a statistic analysis. Basically, we're seeing all the SCI samples, they cluster together, and they're separate and different from the controls. And then what happened after with the microbiome changes is it leads to bacterial translocation. So they looked at, they collected tissues such as blood, lung, liver, and they compared the animals without injury and with 1 day, 3 day, 7 day after the injury. And they grow the tissue or try to grow the tissue, process the tissue in the plate and see when and whether bacteria grow. And then we can see starting from 3 days, bacteria start to show up in the lung tissues, and starting from 7 days, bacteria are present in all the tissues. So there are, in addition to this first study, there are a few more lines of research in animal models that they showed acute SCI-induced gut dysbiosis, bacterial translocation, and intestinal inflammation. These changes in gut microbiome, they may well predispose individuals with spinal cord injury to several chronic conditions or need for antibiotic treatment or psychological stress, which creates a further vicious cycle to deteriorate gut microbiome composition. So this was our hypothesis. We used some data from our research studies, some preliminary data to see if this is, if there's any evidence to support this. So we used age, gender matched participants without the SCI, with acute SCI, and chronic SCI. We have 25 patients. And they have different level of injury. It's kind of hard to control for level of injury for human studies. And the time of stool collection after injury. So for the acute patients, when the stool collected, on average, was 7 days after they had an injury, they're still hospitalized. And for the chronic patients, they were 18 years. They had the injury for an average of 18 years. And because of the nature of acute injury and hospitalization, 6 out of 7 patients were on antibiotics. And for the chronic patients, they are not eligible if they had antibiotics within 4 weeks of the stool sample collection, because we want to avoid that acute antibiotic impact. We observed differential alpha diversity among the groups with patients with acute spinal cord injury, and they have the highest alpha diversity, and the non-disabled controls, they have the lowest, and they're all significantly different from each other. I want to quickly add a note here. We'll come back to this point. In the general research, it's generally considered the higher alpha diversity is, the healthier it indicates. But in the case of spinal cord injury, it may not be the case. They may just picked up some bacteria from hospitalization, or they have some new bacteria grow because of all the medication, antibiotics they're taking. And the group differences were further confirmed when data diversity were compared. As you can see, each color represents a different group. We're seeing separation of all each 2 of the 3 groups. So the acute is separated from the controls. The chronic patients is separated from the controls, and the chronic was separated from the acute. So both the alpha and the beta diversity showed us they are different. They're significantly different. Something's changed. So what changed? What bacteria are changed? I didn't put the whole table here. It's long and it's very complicated. So I just gave a basic summary. And I want to mention that we found what's differently present in the samples, in the groups. What we cannot do is we cannot say this bacteria is doing something, because we're just basically using cross-sectional sample analysis, see what's there. And how we interpret the data is we look at existing literature and see what this bacteria, what other people are saying about this bacteria, what other conditions these bacteria are involved with. So the overall theme is compared to the control group, the microbiome composition in the ICI groups, they share features linked to metabolic syndrome, inflammation-related bowel disorders, depressive disorders, or antibiotic use, which is kind of this hypothesis seems to be valid. And another point is compared to acute and control groups, individuals with a chronic SCI, they share features linked to physical inactivity. So in addition to the 3 we talked about, there are for sure many other health conditions, such as autonomic dyslexia, kidney diseases, pressure ulcers, infection, which we're not really targeting by our studies for now, but it's definitely worth considering how and if we can use nutrition as a way to target these conditions. So where does things stand for SCI patients? We use some of our preliminary data. So we assessed their diet intake and diet quality. So what we found is that they always, on average, consume very poor diet. So this is we calculate the healthy eating index, the HEI 2015. So it's an indicator It reflects whether a person's diet conforms to the dietary guidelines. The higher, the better. So, and then it has 13 individual components. So we can see the green bars are the highest score one person can get, and the blue are the scores from our participants. We can see they're not eating enough fruits, vegetables, whole grains, dairy, and protein and seafood are okay, and they're eating extra fat, refined grains, sodiums, added sugars, and saturated fat. So overall, it's a poor Western diet. So this shows that there's room to improvement, room for them to eat healthier, to improve their health. And we're thinking about what kind of diet to help us better target all the conditions that I just introduced. One particular diet of interest is a lower carbohydrate, higher protein diet with healthy components. So based on research in the general population, there's not a lot of research in people with disabilities, not alone spinal cord injury. So a high protein diet is generally considered to control appetite, so you don't feel hungry. And then they can improve and preserve body composition, and they maintain your energy expenditure because protein has the highest thermal effect of food. That means after you eat protein, you spend more energy digesting and absorbing all the nutrients. And with a lower carbohydrate content, you relieve some pressure of the glucose metabolism system. You eat less carbs, your body don't go into the mode of releasing so much insulin for glucose clearance. So that's our diet of interest. We designed a 8-week randomized controlled trial. Participants were randomized into the study diet or the control diet. The study diet is also caloric. They were designed to maintain their body weight. And it's 30% protein, 30% fat, and 40% carbohydrate. And it focuses on healthy components such as whole grains, lean meat, fruits, and vegetables. And the meals were delivered to participants every week. And the control group, they were instructed to continue with their regular diet. And eligibility, basically all adults and patients with C5 to L4 with complete or incomplete injuries. And they are have to be either insulin resistant or in pre-diabetes, and no antibiotics within 4 weeks of the study, and not previously consuming a high protein diet, and no pressure also. So we've observed using our preliminary data collected, we've observed that the diet improved their body composition. We'll start from here, the fat mass. There's significant time and group interaction effect for fat mass, percentage body fat, and visceral adipose tissue. So that's basically belly fat. The diet group significantly reduced all these three fat components, basically. And their fat-free mass, which is muscle mass and bone mass and other fluid, body fluid, they remain, which is a good signal because they didn't lose more muscle. And in addition, participants in the diet group improved the blood lipid profile. The cholesterol significantly reduced, and no significant effect for triglyceride, but HDL and LDL, there's an interaction effect of time and group. And even though there's no significant change within the group, but the interaction effect means the HDL and the LDL decrease in the diet and then increased a little bit quantitatively in the control group. So there's a superiority of the diet observed. In terms of gut microbiome composition, we observed a reduced alpha diversity among participants in the diet group, as seen here. This is where the point I want to remind everybody. At first, we observed that patients with spinal cord injury have higher alpha diversity, and after the diet, they went down. And combined with all the improvement in the cardiometabolic parameters, it may not be a bad thing. Their alpha diversity went down for our participants. And to further support it, the beta diversity also significantly changed. So in the diet group, the samples before the study and after the study, the right one or after the study, they're separated, and there's a significant effect of time. And the control group, the samples, they're kind of all still mixed together. There's no clear separation. And the next step, we looked at what bacteria communities changed. Also, again, I'm giving a summary and what we think is happening. And this is definitely more of a hypothesis generating observation. And we've observed that bacterial communities that's involved in fiber digestion and metabolism, they were increased. And these communities were seen in the literature, and they're involved in gut microbiome community stability. They alleviate intestinal inflammation, maintain gut barrier integrity, and improve constipation. And there are several bacteria taxa that's implicated in inflammation, metabolic disorders, and cardiovascular diseases. They were reduced among participants in the diet group. And that's kind of consistent with the reduction in blood lipid we observed. So in summary, spinal cord injury may be associated with progressive deterioration of the gut microbiome, a reduced carbohydrate and high protein diet with healthy components may be adopted to improve metabolic health and gut microbiome composition. For the study, there's definitely some limitation because the difference between the two groups is not only the macronutrient composition, but also the control group. It didn't have any healthy components. So whether the changes, was it due to the macronutrient composition or the additional healthy component, that's not is not conclusive. And did the microbiome really confer any benefits, or is it because of the diet? And also long-term safety. We all know potentially individuals with spinal cord injury are at risk of kidney diseases. So whether this can be generalized to everybody, it still remains to be addressed. Future directions. Speaking from my perspective, I have background in nutrition, so I definitely like to explore future dietary manipulations and how it can improve other secondary health conditions, such as pressure ulcer or blood pressure. And also in terms of the microbiome, prebiotics, probiotics, supplementation is a strong research field that we're definitely interested in exploring in the future. And I would like to thank all of my participants, our staff in our lab, and UAB, all the UAB core services and co-Is, and the research funding for our studies. Thank you, and I would like to hear any questions.
Thanks so much. Oh, and we have, okay, screen share dropped. Okay, in the name of time, I would like to ask one question right now. And then after Sven presents, then we'll invite the audience to have questions for both presenters.
Okay.
So in respect to the second study where you had the dietary intervention, first of all, thank you so much for your efforts here. Logistically, I can't imagine what this must have been like to implement this. but you show in one of the bar charts with the significant interaction effect, a decrease in HDL cholesterols. Can you please comment on why you think that might be and the direction of the change there?
Yes, so I think this is now unique to our study. We definitely heard about HDL decreases with sometimes healthy, probably overall reduced carb intake. That's my guess, but I'm now well versed for the HDL question. And we really, I haven't read anything, people explaining it, but it's definitely not new.
Not new for dietary interventions in general or in the spinal cord injury population?
In some dietary interventions, my guess would be because of the low carb, because dietary carb is the precursor for lipid synthesis. So the overall pool of lipid synthesis is reduced, and then you have an overall reduced lipid production. That includes HDL. That's my guess.
Yes, I think this data for the audience and those watching is very interesting. Normally, HDL in spinal cord injury is low, and we have yet to receive an explanation as to why this is so, but it's a very reproducible lipid characteristic in this population. Not only is it low, but it's usually not changing. And so the fact that there's some movement here, even if it's in a direction we don't necessarily want, could be telling us, maybe giving us hints as to things we could do to make it change in other directions.
Yes. Thank you
All right.
for the question.
Yeah, and hopefully more at the end. Okay, I'll hand it over to Raul, one of the other organizers, and he will introduce Sven, the next presenter.
Okay, I think it's time for our next talk. It's by Dr. Sven Hoekstra. Sven received his PhD in exercise physiology at Loughborough University in UK. Sven is a research associate working within the Peter Harrison Center for Disability Sport at Loughborough University in the UK. Building on his PhD work, he investigates the effects of passive heating strategies on inflammatory markers and cardiometabolic health outcomes. Alongside his experimental research, he also works closely with rehab partners in the UK to make a direct impact on preventative care for persons with spinal cord injury through physical activity, functional electrical stimulation, and nutritional interventions. So the title for his talk today is Strategies to Introduce an Inflammatory Response, a focus on alternatives for people restricted from engaging in lower body exercise. Welcome, Sven. Please take it away from here.
Thank you for that introduction, Ro, and thanks for the invite to present. It's a real pleasure. Yeah, I'll skip over the title, though it's a bit different indeed. So I'll be talking about my work on passive heating and a bit about what we're doing at the Peter Harrison Center for Disability Sport at Loughborough University in the UK. So as you can see, we kind of try to span the whole range of the exercise capacity continuum. So we have people working on Paralympic athletes, as you can see on the left, with Paralympic triathlon and wheelchair rugby. But we also do a lot of work on physical activity promotion for just the general population who use a wheelchair. And we are fortunate enough to do that in this building that you see in the middle. And that's one of the 4 national centers for sport and exercise medicine that have been built as part of the legacy of the Olympics and Paralympics of London in 2012. And as part of that work that we've done or that we're doing on physical activity promotion in persons with SCI, our team has made international scientific exercise guidelines for persons with a spinal cord injury. So we've sort of based on a systematic review and focus groups with end users, we've come up with a combination of targets that people can use to work on their fitness and cardiometabolic health. Now we know that from sort of a behavior change perspective, this is really useful to give people the knowledge and confidence that they can work on their health and fitness. Only the more and more I speak with physiotherapists and other healthcare professionals working with people with SCI, I hear a lot of people saying like, yeah, these guidelines are great, but we have so many patients who just don't have the physical capacity to meet those guidelines. And furthermore, that there's some recent opinion pieces and reviews that highlight that maybe even upper body exercise alone is not even optimal for the improvement of cardiometabolic health and body composition. So maybe with that in mind, there is a good time now and there's scope to sort of explore additional interventions and kind of increase our toolbox, as it were, that we can provide to people with SCI. And we know that, for example, FES can be useful, and Jia made a good case for nutrition. But in this presentation, I want to make the case for passive heating as an additional strategy. And yeah, passive heating is not a new thing. We know that the Romans already liked their hot baths, and it's been an old tradition in many countries around the world. Only maybe somewhat surprisingly, in the scientific context, it's still in its infancy. One of the first papers to show that there might be a positive effect of heating on cardiometabolic health is from Hooper in 1999. And he showed that after 3 weeks of hot water immersion by persons with diabetes, that could reduce HbA1c and measures of fasting glucose and insulin. But yeah, again, maybe somewhat surprisingly, that didn't necessarily spur a whole increase in the research interest in the area. So when I started my PhD in 2015, my main sort of goal was to kind of characterize that the acute and the chronic effects of passive heating in a bit more detail. And in doing so, we were mainly interested in inflammation, mainly due to its link with cardiovascular disease and cardiometabolic health outcomes in general. And on the left is an image that has become kind of commonplace when you talk about the acute inflammatory responses to exercise, where we see that after a bout of exercise, you see an acute increase in a more pro-inflammatory marker called IL-6, but that then induces a longer lasting so-called anti-inflammatory response. And the idea is if you do that on a regular basis, you might be able to reduce the chronic low-grade inflammation, which is a main risk factor for chronic disease. And that has been shown after running, but also after upper body exercise. And apart from those cytokines, we were also interested in heat shock protein. And other than that, the name seems logical, that was also based on different animal studies. For example, the one of Chung in 2008, where they showed that increasing heat shock protein expressions through medication or other means protects against the negative effects of a high-fat diet. And in addition, we also looked more directly at glycaemic control and vascular function in response to these heating interventions. But let's start with the acute effects. And this was all in non-injured individuals, so able-bodied male individuals, in response to 1 hour of hot water immersion in water set at 39 degrees. I'll leave you to do the calculations for Fahrenheit. But acutely, if we start with IL-6, we see that as was shown in that picture for exercise, we see that also hot water immersion can acutely induce that what we think is a beneficial response in IL-6. And the same is true for nitrite, which is a marker for nitric oxide bioavailability, which is potentially important for vascular health, as well as glucose metabolism. However, sort of despite the promising findings from animal studies and several reviews that highlight heat shock protein as sort of a key player in the effects of passive heating, we did not find any effects of heat shock protein after that 1 hour in hot bath. And then a follow-up study, we looked a bit more closely at that glycemic response after heating. As is shown here, the study by Christoph Leicht. And on the left, what we've done is people sat in a bath again for 1 hour at 39 degrees. And then 1 hour after the bath, we initiated an oral glucose tolerance test that Jia also explained. So people consume 75 grams of glucose, and then that is followed by serial blood samples for 2 hours. And perhaps somewhat surprisingly, if we think of heating as a tool to improve metabolic health, is that we see that after taking a bath, the glucose concentrations were actually higher compared to after a control condition where people just sat on a chair in a room at ambient temperature. And whether that's a good or a bad thing, I'm not quite sure, to be honest. But we think it may be to do with the sympathetic activation that you get after or during sitting in a bath, where you get the effects of stress hormones like adrenaline on hepatic glucose output, and that might result in the higher concentrations of glucose after having sat in a hot bath. And then moving on to the vascular responses from other labs. So for example, James Cotter in New Zealand showed that both in healthy individuals and also those with cardiovascular diseases, that acutely heating can increase blood flow in both the brachial artery and the femoral artery, which then in turn might induce positive adaptations in the vasculature. So as a short recap, we can say that acutely, so a single session of heating can indeed induce changes in inflammatory markers, in the glycaemic control markers, as well as vascular markers. But obviously this is just a single session, and that in itself is not going to improve health. So we have to look at the chronic interventions and what they tell us about the effects of heating on health. And to sort of make a start with that in our lab, we conducted a study where people took part in 10 hot water immersion sessions, again, the hour at 39 degrees, in a space of 2 weeks. And you can see here that the main outcome from that study, where we showed that both fasting insulin as well as glucose was reduced after those 2 weeks compared to the control condition. So in that case, we kind of confirmed those promising initial findings from Hooper in 1999. In addition, we saw a reduction in blood pressure, but again, there was no change in that heat shock protein or any of the other inflammatory markers. But then in other studies, for example, Brunt et al., they showed after 8 weeks of hot water immersion, 4 sessions at sort of slightly more intense than we used, but for 8 weeks, they saw an increase in flow-mediated dilation, which is a main marker for endothelial function. They saw an improvement there, so suggesting that also for vascular function, that passive heating might have promising effects. And the same has been shown for inflammatory markers. This case by Brett Eli, where she showed in obese women, again, an 8 to 10 week intervention, where markers like IL-6 and TNF-alpha in serum improved compared to a control group. So then together we can say, okay, these sort of proof of concept studies in non-injured individuals, really show quite promising findings and potentially make the case to transfer that to persons with SCI. But then perhaps also in your mind, the first thought mostly that comes up is what about the thermoregulatory issues that are found in people with SCI? We know, for example, from work from Katie Griggs doing a Ph.D. at Loughborough, that if people engage in this case, a wheelchair rugby game, that's the top line is persons with a cervical spinal cord injury, and then the bottom line is the core temperature of persons with either a paraplegia or another impairment. We see that increase in core temperature is a lot larger compared to the persons with paraplegia or other impairments. So that sort of suggests that maybe indeed heating people up or increasing that core temperature to a very large extent is not the best idea. And at the same time, and that's also relevant for interventions in the general population, is that we found that heating can actually be perceived as quite uncomfortable. Although it sounds good to sort of sit in a bath or in a sauna, to induce those changes that we were after, we really increased core temperature quite high. So most studies that we've done, we increased core temperature like 38.5 degrees Celsius. And as you see here at the bottom, we show that the affective response, so basically sort of the pleasure and displeasure that people feel at any given time, that sort of progresses in a negative direction. And at the end of the session, people tend to feel similarly bad, let's say, as we've seen in other studies on high intensity exercise training. So that is scope, and there seems to be need to look at more local or less intense protocols if you really want to make that step to use this intervention in people with SCI and maybe the population more generally. And to do so, we did a study where we wrapped people up in a water-perfused suit, and we had 3 conditions. On the left is kind of the more traditional whole body heating, and in the middle we only heated the legs, whilst we cooled the upper body with both the water-perfused suit as well as ice packs that we put on the body. And that was really to prevent that large rise in core temperature that you generally see with heating studies. And on the right, we had a control condition where people were kept at sort of thermoneutral temperature. Again, these were non-injured individuals, and we looked at inflammatory markers, glycemic control, and arterial blood flow in the femoral artery. And we were also interested in those perceptual responses again. So first, the rectal temperature. So that's a main measure of core temperature. And we see that whole body heating protocol, as expected, and as we've seen also with our hot water immersion studies, that went up, quite high to sort of like 38.5, 38.7 degrees Celsius. But you see also that upper body cooling was indeed effective to avoid that large rise in the core temperature. And that also avoided that dip in the feeling scale, in that effective response during the session. So people tended to feel less bad during that localized heating compared to the whole body heating. And the promising thing is that when we looked at IL-6 then, so this is the area under the curve over a few time points after heating, that was similar for lower body heating compared to the whole body heating. And also when we look at arterial blood flow, we see that although it was a smaller increase when compared with whole body heating, that lower body heating still increased femoral artery blood flow compared to the control condition. Again, potentially inducing adaptations in the vasculature in the legs in this case. It was not all good news though. If we look more sort of widely to the inflammatory markers, this is a bit of a busy slide, but on the left you see again that nitrite, so a marker of nitric oxide bioavailability. We see that only the whole body heating protocol, so on the right, that induced an increase in its concentration, but it wasn't the case after lower body heating. And the same was true for IL-1RA, which is a sort of a key anti-inflammatory marker. That was increased after whole body heating, but not after lower body heating. And we again also did an OGTT, so an oral glucose tolerance test, and we kind of confirmed the findings that we saw earlier, where we have that elevated glucose concentration after heating. As you can see on the right, it was the whole body heating protocol, but this is not shown after the lower body heating, nor the control. So there was no difference between the lower body heating and the control condition. And again, whether that's a good or a bad thing, I'm not quite sure. I guess acutely, you could argue that the absence of that hyperglycemia after heating it could be an argument for some people to advocate the lower body heating over the whole body heating. But at the same time, it might be part of the responses that you need to have adaptations in glucose tolerance. Then if you move on to the sort of more vascular outcomes, we did a study with Jen Cheng from McMaster University, and she is a lot more inventive than I am. On the left, you see the water tub that she used. So she really went a step further and did a very localized heating, where she heated only the ankles or up till the knee, and then used some of her own kitchen equipment, as you can see here, the sous vide, to maintain the temperature of the water in that tank, which was 45 degrees Celsius. And as you can see here, for core temperature, this was in this case done with a pill to look at gastrointestinal temperature. That increase is a lot smaller than we've seen in our other whole body heating studies. So it's a very modest intervention. But despite that, the less intense heat stress, she showed that acutely there's an increase in, again, that flow-mediated dilation as a marker for endothelial function after both interventions. So yeah, taken together, like we've shown that, okay, acutely passive heating, almost like exercise, can induce changes in inflammatory markers, glycemic markers, as well as vascular markers. And many of these responses overlap actually with the responses that we find after exercise. And also repeated heat therapy can improve aspects of cardiometabolic health. And to do so, there are some, we've shown at least some sort of preliminary evidence that localized heating protocols may be available to sort of induce those similar responses. But I have to, admit, obviously, like the research in people with spinal cord injury is still limited. And that is kind of the next step in the journey that we are at in terms of the passive heating research. There is some preliminary evidence from Christoph Leicht that he did in Japan with our partners at Microbiome, where he showed that acutely, again, people with a cervical SCI, first of all, can safely engage in an hour of hot water immersion, again at 39 degrees Celsius. And that also induced an acute IL-6 response in this population. But the thing I'm most excited about at the moment is that we received funding, NIH funding, to start a chronic intervention in persons with SCI starting this summer, where we will ask people to engage in 8 weeks of passive heating intervention, where we use heating blankets to raise that core and skin temperature. And again, we will look at glycemic control, vascular outcomes, as well as inflammatory markers. But for now, I want to thank you for your attention, and I'm keen to hear what your thoughts are on heating as an intervention for people with SCI, and happy to take any other questions as well, of course. Thank you.
Thank you, Sven. So if you can stop screen share, and I think everyone can come in now with cameras on. If you have questions, we're inviting the audience. Come on in, raise your hand. You can drop your question in the chat. We'll read it for you if you would like us to. Raul, it looks like you have a question for Sven here, and you might want to, just read it out.
Hi, Sven. Great talk. I'm just wondering, how does this fit in conceptually with all the research that has shown that hypothermia, cooling down of the body, reduces inflammation, reduces excitotoxicity, preserves the blood-brain barrier, reduces apoptosis. There is just a lot of work being done with hypothermia, reducing the body temperature and preventing secondary injury. So, and you mentioned a lot of times the word acute acute treatment. So is it acute meaning a short duration of treatment, or is it acutely after spinal cord injury?
Yeah, sorry, that last thing is maybe a bit confusing indeed. I should have made that clear, but with acute, I mean indeed just immediately after a session of heating.
Okay.
So it's in the hours after.
I see.
Yeah. And to sort of come back to your first question indeed, and that's an interesting point indeed, because it seems almost like contradictory, but I think they share commonalities indeed. So we have colleagues in the Netherlands, for example, who do a lot of work on also the metabolic responses to cold therapy, as they call it. And we see, for example, what we shown with the glycaemic responses, that again is very similar in after cold stress. And we're actually now preparing, or we almost starting a study where we look at this in like cold therapy, but then through cold showers. So trying to sort of have a bit more of an accessible intervention in people with SCI, to see if that can indeed also improve cardiometabolic, but also sort of functional outcomes. And I think maybe part of the reason why these responses are similar is because of the sympathetic activation that you get, at least in the non-injured individuals, in terms of the increases in adrenaline and the other stress hormones that have sort of, and cortisol perhaps, that have sort of a knock-on effect on other physiological systems. So, and just the disturbance of homeostasis, that is like rather than exercise where you disturb homeostasis, it's like an environmental factor where you have a slight disturbance to the system, which then leads to adaptation. So I think that is where maybe the commonalities are.
Thank you.
Looks like Jared has a question. Jared, if you'd like to ask that question yourself, you can, or we'll read it off.
Sure. Thank you both for your talk today. Excellent. So my question was in regards to portion control to Jia. I wasn't sure. I know you talked about the 30 and 40% with carbs, proteins, and fats. I was interested in if there was any controls around how much, like the amounts, and then also there's been a lot of research for people without spinal cord injuries lately around intermittent fasting and time restricted feeding windows, keeping it between 8 and 10 hours every other day, and different things like that. Just wondering if that was on the horizon, or if that's been thought about or looked at.
I think those are definitely interesting ideas for our study. We didn't control when they eat the meals. We actually give them some flexibility, like when they can eat their meals. Like they can even switch out within the day. They can switch out the meals just to improve compliance. Because some people are not breakfast eaters, and if you give them a big breakfast, they're not going to eat it. Or vice versa. So that's not something we've looked at. I know what you're saying about there's a lot of research on different ways to manipulate diet and timing. But for SCI, I think we're definitely interested, but because of the feasibility and the limited resources. So at least now there's no research in SCI on these topics. Like we're only one of the field that looks at different dietary manipulations in SCI. But I know there are, including our group, we're looking at the ketogenic diet in acute SCI recovery. That's my main coursework. But other diets will definitely be of interest. Actually, I'm looking at a diet and blood pressure control originally got some pilot money to look at that, but it's not on the two areas you were mentioning.
Hey, to keep pulling on that thread, in the general dietary literature, it's been shown that the characteristics of a diet can track or manipulate the microbiome phenotype itself. And it looks like you have data in spinal cord injury and non-spinal cord injury. Have you looked at this in your data?
The phenotype?
Yeah, like the proportions of different microbiome categories.
No, not really, but we've seen, I know what you're saying. I think they look at the proportions of some predominant taxa. We didn't look at it, but we're seeing like changes in one of the predominant taxa. It's Hoekstra. It's a big taxa. Yeah, actually, that's one of the confusing part because microbiome data is quite complicated. Like even within a family of bacteria, there's different genera. I forgot the word. Within the family, there's order and there's genus, and then species, and each one of them does have different functions. So that's why we didn't really look at those one area. We're looking at the whole picture, what was all together doing. But I know what you're saying, and we haven't looked at it.
Seems like an opportunity.
Definitely.
Sven, I really appreciate that you're trying to apply this heating high volumes of upper extremity exercise for people with tetraplegia, sometimes infeasible, and the equipment to do lower extremity like FES can be expensive, right? I think it's quite practical. But let's say not just as a training stimulus. Do you think that your test has like a diagnostic potential? So you showed some data from the Griggs paper with a heat map of someone's body and a line on the body where the heating stopped. What do you think about that?
Yeah, that's a good point. To sort of use it almost to determine the level where the autonomic function stops or starts. Yeah, no, that's an interesting one. I think also maybe more so than like really specifically for SCI, this kind of heating as a tool to look at vascular or metabolic health has been used more generally, where you look, for example, when you heat a small part of the skin and look at the blood flow response in the skin, can be a marker for vascular function or endothelial function. So that's for example, something where it could be useful. But you need to look at the level. That's an interesting one, actually. I hadn't thought about it, but that's a good point. And maybe something like that, what a few suit where you can sort of to quite a detailed extent heat specific parts of the body. That could be quite a nice avenue to do that. Yeah, nice.
I have a small comment on Sven. Actually, you know what? While I was doing some literature reviews for meals and cardiovascular responses to a meal, because eating a meal is a cardiovascular event, like after the meal consumption. And there are actually the literature showing the temperature of the meal affects the cardiovascular functions. And it's kind of related to how fast your food are consumed and then entered into the body, and then all the hormonal and metabolism, and then it affect your blood pressure, your sympathetic nervous system reactions.
Interesting. And in what direction did it affect?
I want to say the warmer the meal, the one I'm looking at is blood pressure. Is the more the warm the meal, the drop in blood pressure, which is not a good thing in after a meal consumption.
Yeah, good point. Yeah. That's interesting. Yeah, it could be. Do you think it could be to do with the vasodilation that is a direct response of to the heat?
It's a combination of things. It's kind of all linking together. Like my understanding is the meal, the temperature of the meal determines how fast your meals are absorbed and digested, and then how fast you have all the blood sugar entering your blood and blood insulin. And insulin is a vasodilator.
Yeah.
So the temperature of the meal kind of consequently determines your blood pressure.
Yeah.
One of the strategies to in the literature, one of the strategies to prevent the drop of the blood pressure after you eat is actually eat a cold meal.
Yeah, interesting. They've done some studies where they, for example, with insulin, when you inject insulin to sort of heat that area of treatment, let's say, and that in itself, that sort of local effect also had an impact on the uptake of it. But this is an interesting avenue. Yeah. No, thanks.
Yeah, it's interesting how like it's all connected.
Yeah, definitely. Yeah.
The parallax perspective is working. Ellen, would you like to come in?
Yes, thank you. So I work in the autonomic unit in London, UK. So I'm testing the autonomic nervous system on a daily basis. And as you said, Lee, postprandial hypotension, we do see that quite frequently in spinal cord injuries, and the higher the level, the more postprandial hypotension. We all have a nocturnal dip normally, so we have the lowest blood pressure in the morning. So if you have a big meal, it's the volume, the heat, a hot meal, a lot of carbohydrates. So if you have a full English breakfast with alcohol in the morning, you've done it. That's the best way of getting postprandial hypotension. I am concerned about the heating. I have had several tetraplegics who are unable to sweat. And I've done heating blanket with them, and they get very, very poorly. You get the flu ×6. So I would be quite concerned about your heating up. And we do exercise testing on patients, and we do see that they either have a blood pressure drop during exercise or after exercise, or both. So I would be cautious about monitoring their blood pressure and heart rate during the heating. And yeah, I'm concerned about what you're doing. It's good in healthy volunteers, but I would be cautious in spinal cord injuries.
Yeah, no, that's an excellent comment, and that's indeed why I also sort of included that caveat that we have to be really careful about this. And yeah, obviously monitoring is the first thing we do, and we've shown I showed a few studies where we have used this approach in people with cervical spinal cord injuries. So I don't know whether they were, I don't know, maybe yours were complete, and
yeah,
I think a few of those were complete as well. But so we have shown that it can be done, but there are indeed issues, like it's not only the initial increase in core temperature, but it's also when let's say a non-injured individual, when we see, okay, this person is getting a bit too hot, we can take them out and we cool them directly, and that can have quite a quick effect. Whilst in persons with SCI, and I don't have to tell you, but it's a lot harder to cool people down quickly.
Oh yeah, yeah.
So
because we use a heating chamber.
Okay.
We have a heating chamber in London, so we monitor. Do you have a continuous monitoring of blood pressure and heart rate when you do these tests?
We will look at that. Yeah, that's definitely.
Yeah, I would recommend that to make sure that it's safe. And I've seen incomplete tetras who's been able to walk again and still having blood pressure drop both during and after exercise. So I had one who was able to actually run, and the day before he was discharged, he fainted. He collapsed when he was running, and we could show putting him on the treadmill and having continuous monitoring, we could see that as soon as he stopped running, boom, he had a nosedive of his blood pressure. So when we taught him to decelerate, he stopped fainting.
Yeah, no, there's important comments, but at the same time, I also think, just as a sort of counterpoint, that because of this, we don't tell people to not exercise, right? So it's still like we are at the start. I appreciate that we are at the start of like exploring this, and we have to be careful and sort of go step by step. But yeah, it's not necessarily, if we monitor this rightly, and if we can say, okay, we can get away with heating only the ankles, for example, as we've shown in Cheng's study, that might be a way to still induce part of these benefits without, as you say, giving people a fever straight away. Can I ask, by the way, how do you employ the heating then? What kind of?
We have a heating chamber,
And
similar to what they have in the Mayo Clinic in Rochester.
okay, and how do you?
So that's a state of the art. So we look at that for most either hyperhidrosis or anhidrosis to document that.
Okay.
So yeah, but we are careful we never increase the core temperature more than 1 degree.
Yeah, no, I agree.
Yeah. And because then we have stable humidity and stable temperature.
Yeah.
This is a great conversation. For the practical implication aside, there's also a hint biologically here. The somatic and autonomic levels of injuries might not track with each other. And I think that's an important probably area of study for early career researchers to pick up. So in the manner of time, thank you all for coming. Thank you so much to both of our presenters. Thank you to the audience. This was a great engaging conversation afterwards, and keep it going. You can find these people's contact information, I'm sure. And I know they're both at least on Twitter. And so you can spark a conversation up there about this. The Asia Early Career Webinar Series was founded and organized by myself, David McMillan, Annie Palermo, and Roel Sacheva, who's here, and is part of Asia's Early Career Committee. So thank you to all of those people. And as a special bonus information right now, the webinar is looking for an production assistant volunteer. So if you are an early career person and you would like to volunteer to help us organize this series, please reach out to us. And you can DM me on Twitter. You can find my contact information online through my papers where I'm a corresponding author. Thank you all so much for coming, and goodbye. We'll see you next time.
Thank you, guys.